Eva, come Kevin and Lauren.
We've been working on the compost facility since 2010, and eventually we came to kind of a joint venture project with organics from single-family residential materials and biosolids. I'm going to give a quick synopsis on the organics part of it, the single-family residential part, and then Kevin's going to talk about the biosolids feedstocks that we're accepting. So this is a picture of summer feedstock. This is coming from our current pilot. The pilot's been going on for what, I think 3 years now. As you can see in this picture, a lot of green material. The actual program is food and yard waste, so all the organic waste that comes from your home, and then all the yard waste that can come from your single-family residential home as well. As you can see in this picture, a lot of green waste. Majority of this pile is actually yard waste. So one of the large misnomers out there is that landfills are not giant composters. They, a lot of people think that by putting organic material into a landfill, you're actually somehow inoculating the process and making it more rapid, the decomposition. In fact, that's not true. Organics break down in the absence of air and create methane, rather than what they would normally do in the environment, which is break down with oxygen and create CO2. And methane is 25 times worse for the environment from a climate change perspective than CO2. And so here's a few pictures of this example. In this right-hand picture is a picture of a newspaper that was pulled out a couple years back when we were doing some excavating around the landfill. That newspaper is from 1974. Amazing. You can see the gentleman with the cowboy hat on. It's right around stampede time. In the picture on the left is some chicken bones from that same excavation. Been in there for 30 years. So we did a pilot, and in that pilot, we determined that around 65% of the available material was organic and could be composted. And that was done through a waste composition and waste characterization study in 2014. So basically, all the material that was eligible to go into our compost facility was about 65% of your waste. So if you have a black bin right now, you can imagine it being 65% lower. So how did we come to the conclusion that we needed a compost facility? We did another waste composition study in 2011. And what we found was similar numbers. This is a waste composition study. The pie graph on the left is a waste composition study, and it looked at all the waste sectors. Not only single-family residential, but the other waste sectors in Calgary, multifamily, institutional, commercial, industrial, construction and demolition. And what you can see there, these numbers are out of date. We've done a number of waste compositions since then, but what you can see there is there's a fair amount of waste going into our landfills that could be composted. On the right, you can see there's a breakdown of the pie graph on the left. You can see the different waste sectors and the organics coming from those waste sectors. Single family is the large piece on the right here, the light green portion. And all the colors on the left-hand side of that pie graph are privately collected organics. So multifamily, institutional, and commercial. And they're privately collected by about 35 different waste collectors in Calgary. And they control the destiny of where that material is processed. We, on the other hand, collect all this light green portion of the pie. In the single-family residential, you don't really have an option to fire the city of Calgary to collect your material. So we have a monopoly on the collection of that 110,000 tons. And so what we decided to do at the time was, because we didn't have control of the destiny of those privately collected organics, we decided that we would focus on what we controlled, and that was the single-family residential. So what we decided to build was a facility that was dedicated strictly to single-family residential organics. As I was saying, we did a pilot. And the pilot was there to measure customer satisfaction primarily and the customer experience. It was really not about how we figure out the sizing of the facility, although it did help. The primary drivers for it was how we actually unroll citywide green card. And so we were looking at, how often we pick up black card, how often and when do we pick up green card and the blue card. You can see here, those of you who live in Calgary and have a single-family residential home, you can see the black card. This is a 240-liter cart. Again, the same with the blue, it's 240 liters, and then half the size is 120 that was piloted. We're actually working right now on determining whether or not this size is the appropriate size citywide. It's automated collection, much like the blue and the black cart that you probably experienced. It's got an arm that picks it up and puts it into the truck. So what we saw, that pilot was done over 4 communities, 7,500 homes. It was a fairly large pilot by Canadian standards, and it had pretty good results. We saw very good results in comparison to other municipal standards. What we saw of the available 65%, we saw pilot communities diverting about 40%. So we saw a 40% reduction in the materials that were going into the black card. That equates to about an 85,000 to 100,000 ton feedstock going into our composting facility on day 1.
So biosolids are a nutrient-rich soil conditioner and fertilizer resulting from our advanced wastewater treatment processes here in Calgary and elsewhere in the world. What you see here is actually the water cake of biosolids, centrifuged biosolids. We push about a third of our solids that are moved to the digesters are from primary sludge, from our primary clarification process, and about 2/3 from our waste-activated sludge that's used, essentially bacteria used in our secondary treatment processes that are wasted to the digesters. And that's thickened to about 2 to 3%, which is essentially still a liquid form, although it's referred to as sludge and pumped to the Shepherd Lagoons. It's a gravity process at the Shepherd Lagoons for separation of those materials. The water is pumped back to the Bonnybrook plant for further treatment, and the sludge is thickened to about, well, ideally 6% minimum for use in our land application program. We struggled a little bit with that 6% this year. And with our new equipment, it's been a real challenge, but I think we're up over 6% now, and the equipment's been calibrated to ensure success of that program for 2015. So all the other processes outside the land application, which uses a liquid form, require dewatered biosolids, and that's what you see here. And in the head. So pre-2011, the Calgary program started in 1983. We're going to try and get 32 plus years and counting of the city's biosolids program in the next 4 slides here. So pre-2011, 1983, we started the Calgary program. What you see here is a Terrigator. That's our field application equipment. What's drawn behind that is a injection table. There's a tank on the back of the truck. We haul with tanker trucks and trailers about almost 10,000 loads of biosolids from the Shepherd Lagoons to the fields within a 50-kilometer radius roughly around Calgary every year, between the months of the 3rd week in May and hopefully the end of October every year. We apply to about 4,200 acres of land, which is about twice the size of Nosa Park. It's a sizable operation, very seasonal, 24 hours a day to move that quantity. We produce about 23,000 dry tons of biosolids a year from the plants, and the Calgary program has a capacity of about 12,500. That's our target number, variable based on the weather for the most part. Other challenges with Calgary, potential regulatory change with respect to phosphorus and pathogen levels. um, public perception around land application. There's a lot of misinformation and rumor out there in the public around biosolids and biosolids application. And diversification. Anyone that I've talked to about the biosolids programs in other municipalities or jurisdictions, anyone who got into trouble with their program and didn't have any outlet for their biosolids really had all their eggs in one basket. So in 2011, it was recognized that we were having an issue. We had increasing population, increasing quantities of biosolids in the lagoons. The lagoons were filling up. Cowgirl was at capacity at around that 12.5 mark, and we had a real issue on our hands. So at that time, we teamed up with Waste and Recycling and kicked off what was termed the Waste Organic Materials and Biosolids Master Plan. This was a significant piece of work across the divisions, involving many sessions and many man-hours of our staff's time. And in the end, ended up with a 736-page report. So it was a significant effort. And really, it outlined 5 things that we needed to do around our biosolids program to diversify and ensure the resiliency of that program. The first one was optimizing cowgirl. So we learned that the limitations in cowgirl were really around the trucking capacity and hauling capacity. We did add trucks and trailers to the fleet at that time, and that increased our ability to keep the application in the field equipment busy, rather than they were actually waiting for the trucks, and we were farther from the city. So that was done. And I wouldn't say that increased our capacity to move more biosolids out, but it lowered our risks that we'd be less affected by it when weather events did. Optimizing wastewater processes, we have limited capability to do that, to lower the quantity of biosolids produced. We're somewhat limited right now by digester capacity as well, but that will be remedied in the future. And there are other processes that can be put in that will reduce the quantity of biosolids produced, but those aren't currently funded or constructed. So the third one was investigate alternative beneficial use options, and in 2010 and 2011, we on site at the Shepherd Lagoons dewatered biosolids, and they were sent to landfill, and some of them were composted in Strathmore by a private company. Speaking from experience at the landfilling of biosolids is really a poor option. Very difficult to deal with because of the polymer required for the centrifuging process. It's very difficult to work with. It doesn't dry. A pile of centrifuged biosolids will develop a crust on the surface. When that crust is scraped off, even 2 years later, you still have a bowl of jelly underneath. So very difficult to work with. Word environment required that it always be disposed of on a lined cell, and it interferes with the day-to-day operations of the landfill sites. So not a desirable option. And then the 2 last ones were really about moving to a permanent solution, which involves a dewatering facility at the Bonnybrook plant to dewater the Bonnybrook sludge. And that's an $80 million project, roughly. Ian Lund was here, he's looking after that for us. And that'll be completed in 2017, late 2017. And also build a composting facility to compost that dewatered biosolids from the dewatered facility at Bonnybrook. So like I say, post 2011, so starting in 2012, we issued an RFP for that third option to have some folks come forward and provide proposals for alternative beneficial uses. And we were able to contract with a very good consultant contractor that has some really unique projects that we eventually decided to go with. There were 2 projects, and they're still ongoing today. One of them was a marginal land reclamation project, which with the purpose of increasing soil capability. Any land in Alberta that's correct me if I'm wrong, Jim. If any land in Alberta is you have to select a crop based on the capability of the soil. If you can't grow anything in it, it's considered poor or marginal. And the idea there is to bring that soil up to a higher standard. So we're doing that, and we're also planting 1,000 acres of a willow biomass plantation. And what you see in the center photo is a willow, and that would be in the ground for about 2 weeks in the center. On the left, you see Natasha Harkham, our agrologist here that you recognize from our Regulatory Affairs and Compliance group, who helps us out a lot. And that's about 4 months on the left in the first growing season. These things are quite vigorous. And on the right, the plant on the left there is the end of the first growing season, and the one on the right is actually the end of the second growing season. So you can see the significant growth potential that these plants have. And there wasn't room for another shot, but when you put all of those together on the right, you've got a jungle. And even from the perspective of habitat restoration or prevention of wind erosion in the field, you can walk 6 feet into this jungle, and the wind is completely gone out on the prairie. So it's a really exciting project, and I think we have some tours coming up, or at least one tour. Don't quote me on that. For a number of different parties, and one of those parties will be interested staff from the business, and I would encourage you to go and see it. It's a pretty exciting thing to see. Unfortunately, I'm not that tall. That's not me. So this last slide here is just a bit of a summary visual of where we're at today and where we're going. On the left, we have the red block at the bottom. Calgary will continue to be our base solution for managing and beneficially reusing biosolids. The Calgary variable portion is related to weather. The red portion is our 12.5. The pink portion is whatever else we can get out based on weather. And on the left, we have our contract work, which is the little biomass plantation and marginal land reclamation projects. In 2017, those projects will end, unfortunately. Now that we've actually started those projects, it would be fantastic if we can continue, but we've gone from feast to famine with biosolids quantities, and we went from a crisis of having too much to we've got some great solutions now. We'd like to continue with these, but we don't have budget or biosolids. So I don't know if the contract piece you see in the center bar will continue. I don't think so. I don't think we have enough biosolids. And then in the 2011 master plan, it identified a third option that was going to be required beyond, at that time the year was 2028. And that third beneficial use could be one of these contract projects, or it could be something else at that time.
So like Kevin was saying, at one time we were actually talking about having 2 separate compost facilities at the City of Calgary, one for biosolids, one for a single-family residential program. And in 2012, we worked together to kind of merge the 2 projects into one. And that's what this this drawing depicts. Like a typical engineer, it's bar graphs, but so what you can see on this drawing is the green is the expected material coming from a single-family residential program. You've got the winter months, the numbers on the bottom depict the number of weeks in the year, and on the sides, the cubic meters that we were expecting from the different programs. What you can see in the winter months when yard waste isn't being generated, that we have this very flat projection. Food waste is pretty steady. People don't tend to ramp up and down the amount they're eating depending on the year. It's base load, basically, and if you were to strike a line across here, you would get about the same amount of food waste year-round. And what happens is, during the growing season, we get this giant peak of yard waste, culminating basically in the month of June. There's about a 3 or 4 week period where grass is green, people are cutting their lawns, cleaning up their yards, and all these yard waste is being produced. So at the time, we were looking at building a facility that would kind of handle this peak for single-family residential. And what it meant was that we had this giant facility that was half unused. big portions of the year, half of it was sitting empty. And so where we decided to come together was that we would use that space to compost biosolids. And so that's what these black bars depict, the amount of volume coming from the biosolids dewatering plant. So the idea is that Cowgirl will continue to function during the summer months, as it always has. And in the winter months, we would be dewatering cake and sending it to the composting facility. So we got our utilization rate up much higher, up in the top here. The red line in this drawing actually depicts what we were shooting for in our contract as far as what size of facility we were asking for from the contractor. And in fact, they gave us one that actually met up here at the end of the day. So what are we getting? This is the proposed compost facility. This is a rendering. We're currently in design now. But this would be a picture kind of looking northeast. Those of you who are familiar with the Shepherd landfill, the throw and go and the scale are off to the left here. The main building here is very, very large. Very large. And to put that in context, those of you who have seen that area, we have some truck shelters in that area, and they're very impressively large truck shelters. Those truck shelters, this building here is 4 times the size of one of those truck shelters. Very large. It would be kind of comparable to some of the warehouses like Canadian Tire and Walmart warehouses that you see around town. Very, very large, measured in hectares. We also have an educational function. This is the administration and education facility. Will be a LEED Gold facility. City and contractor staff will exist in this building. Up in the top here, you can see this small building. That's actually a classroom meant for education. We're trying to implement this kind of cycle of which we're teaching children to divert materials away from the waste process and make a new cyclical economy where our waste cycles back into the economy as a resource. This picture here, you can see the receiving hall. This is the biosolids receiving part. So these doors here are for biosolids. The other side here is the single-family residential trucks receiving area. So I'd say about 20% of this building is for receiving and pre-processing. It goes into a compost process, which I'll describe in a few minutes. And then about a third of this building is dedicated to odor control. So when the air that is foul air that's created out of the composting process is actually captured and treated before it's being discharged. So where is it located? It's located at the Shepherd landfill, very near the lagoons. So for those of you who know where the lagoons are, it's formerly the Ray City Speedway site. You can't see the Ray City Speedway in this picture anymore, but it would have been located right around in here. The main facility that I was showing you in that previous picture is up here, and I was telling you about the scale house at Thorogo. That's where they are. And to put it in context, I was telling you about those truck shelters. That's one of those truck shelters up in the corner there. 4 times the size of that building. It's quite large. It'll dominate the landscape here. This is a picture looking north, by the way. This is Stony Trail, 114th Avenue here. And then if you were to be able to see further down, you'd see 130th Avenue in the community of Copperfield and New Brighton. So the approach we took on this project was that we pre-built a campus. And similar to university or college campus, we actually built an industrial subdivision that would house future diversion programs, with the intent of the first tenant of that campus being the organics facility. This is a picture of all the proposed work that we have coming and future work. Red is proposed and blue is future. Well, we've got things in there like a future anaerobic digestion facility there. We've got some work for a materials recovery facility and other diversion programs that kind of support our 80% diversion target. So what we did there was we pre-built the roads, the utilities, the stormwater system, the water system, shallow utilities, all that to enable future diversion facilities to come in and just build rather than build a whole bunch of on and off-site infrastructure to make it happen. So what do we do currently? This is how we currently compost. This is called open windrow composting. You can see the windrows here. Big piles of material. And what we do is we have a actual blender, so to speak, a turner that straddles the pile and actually turns it over. It's it takes some skill to do this, obviously, but it's not super complicated. We looked at doing this process when we were talking about going citywide, and what ended up happening was that we would need vast quantities of property to make this process work. And why? Because in this process, the factors involved with composting are all controlled by the environment. So the weather. So the three major factors in composting are temperature, moisture, and air content. The air content we can control by turning the pile, but obviously the moisture content and the temperature of the pile are weather dependent. And as you know, we have long winters here. That makes this process quite a long process. So those of you who backyard compost probably know that. It takes a year and a half to make proper compost in your backyard. And so when we looked at what we needed to do to make this work for the volumes that we were going to get from a citywide process, it just wasn't feasible. We had to go to an industrialized format. And that's what this slide presents. So this is how we industrialize the process. So up in the top left corner here, you can see the composting vessels. Each one of these squares that you can see going into the facility here is a giant door that comes off the vessel. And they actually fill this vessel with material. Prior to that, they take it, they blend it with wood, and make sure that the pile has a certain amount of porosity, so the air can actually get into the pile. In the bottom left here, you can see how they actually inject the air. So that's an air header, so it's pushing air down into these vessels, up into the bottom of the floor, and pushing it up through the pile. Through that process, obviously all the air in that vessel is actually quite foul. And so we actually have, like I was pointing out before, we have a fairly extensive process to scrub that odor out of the air before we discharge it to atmosphere. So something that we can do in the open windrow process in about a year, if we're quite successful and the weather works on our behalf, we can do in 21 days in this vessel. And how we do that is we control those environmental factors. We control the amount of water in the pile, we control how much air that's going into the pile, and we monitor the temperature. Here's a couple photos of existing composting facilities in Canada. This is the Guelph facility, originally small facility, but it's considered the gold standard of composting facilities, and it was kind of what we were shooting for as far as what we wanted as an end product out of our contract. Hamilton, a very similar concept. They have a very long-standing organics program in Hamilton. I don't know if there's anyone from Hamilton in the room. Very, very good legacy, very long legacy, and very clean track record. And it just so happens for both facilities we end up with the same operator. So how did we get to the place we're at today? In 2013, we released a request for qualifications to the market, the national market. What a request for qualifications is basically a narrowing down and a pre-qualification of vendors to make sure that they're qualified to bid on such a large project. So making sure that they have the financial capability and the technical capability to actually make this project work. That was done in 2013. We had very good response on that. We had 7 consortiums, and a consortium is made up of a design, build, and operator. So we actually had 21 different companies involved with that response. And it got international attention. There was a number of vendors from Europe, UK, Spain, and the Netherlands. So it was getting international attention, and through that RFQ process and the following RFP process, we had people coming back and forth from Europe to bid on this project. So it was getting a lot of attention. From that 7, we narrowed down to 4 consortiums. And when we released RFP, the 4 got that invitation. The 4 that we had also had European teams involved in them. So 3 out of the 4. They were flying, like I was saying, back and forth from Europe to bid this project. So in 2015, in spring of this year, we closed those bids. And part of why it took so long, you're probably saying July 2014 to June 2015, that's quite a long time. Why would that take so long? Through the design, build, operate process, they actually design a facility for you. And then they bid the price of which that facility costs. So we actually had 4 separate designs and ways to tackle this project with 4 different types of technologies and approaches. So over that year, they were designing and bidding that project. That closed in June 2015. And from there, we selected a group called Chinook Resource Management Group. It's a special purpose vehicle, as they call it. It's a numbered company in Alberta. It didn't exist prior to this project. It's a consortium between Stantec. Stantec is one of the larger design companies in Canada. Bird and Maple Rhiners. Bird is one of the top 5 biggest constructors in Canada. Maple has done a fair amount of work for us in this municipality. Bird has not. And then an operator from Southern Ontario that has done some of the photos that I've shown you before, Hamilton and Guelph. They operate those 2 facilities. So at the end of the day, what ended up happening was basically a Canadian company won the bid. They are using a European technology, but it's a Canadian company that won it. And I think that's a good news story because we competed directly against European business and we won. So this is Calgary's first P3 contract, and what P3 stands for is public-private partnership. And that's typically an alternative delivery model of some sort, design, build, operate, and design, build, operate, finance. It's Calgary's first one. There's been a number of attempts to do P3s in Calgary with not great results. And they've been in the media as not great results. We were the first to actually get to an executed contract. And what we've done is a design, build, operate, maintain, and construction, and with construction finance. A little bit different than some that you've heard, where these deals are over 20, 30 years. We've actually just done a construction financing term. But what that means is that the same company will design, build, and operate the facility. Very different than what we normally do. We typically have this process in which we get a designer, the designer outputs drawings, those drawings are sent to the market for bidding by a contractor, and then after the contractor is done, we turn over to typically our public operator, ourselves. This is very different than what we do. By volume, we're probably 99.9% of all projects at the city go the traditional format, and this is quite rare. So where are we at right now? We intend to complete the design by Christmas time. They started in around June of this year, starting the design, the detailed design. So they had a proposal design, and they've taken that proposal design up to detailed. One of the big factors in these design, build, operates is that they can design and build at the same time. Very different than the traditional format where it's very linear. They complete a process and then hand it over. This process, they are doing them at the same time. So they're building the foundations well, the structure's being designed. And that's really where this contract model is successful. It takes up a lot of time because the 2 processes can happen parallel. It takes a long time to set them up and plan them and get them through the process, but once they're moving, they go much, much more rapidly. Construction began earlier this month, early September. It's expected to be complete in mid to late 2017. One of the things that is a requirement is that we actually have to turn on the single-family residential program to get enough material to properly test this facility. The pilot is so small in comparison to the size of the facility, we couldn't actually test the facility with pilot materials. We actually have to turn on an almost entire quadrant of the city to actually get enough material to make sure that this facility works properly. And so what we'll do when the facility is ready to go, we will turn on the green card program quadrant by quadrant or community by community and bring in the material to start testing it. So if that is expected to be done probably close to the end of 2017, you'll start to see green cards rolling out in 2017, depending on which end of town you live in. Biosolids is expected to come later on in 2017, maybe early 2018, when the dewatering facility is complete. We were in a very unique position on this project. When action plan was being established, it was a council priority. It was one of the few times that council has actually specifically said they want a specialized project. Typically, our action plan is set at kind of the program level and kind of the initiative level. And in this case, they actually specifically asked for us to build a compost facility. Very, very different than what UEP normally does business. We normally set up an action plan and they say yay or nay and tweak it. In this case, they gave us the advice, we want you to build a composting facility. So our council is fully behind this, and we've got a number of directives in the action plan to support it. So in summary, we have to do organics diversion to achieve our 80% diversion target. Without organics diversion, we will not make our 80% diversion target or our long-term target of zero waste. We are also doing biosolids management as part of that process and having a second basket of beneficial reuse. It's Canada's biggest indoor composting facility. I don't think I actually mentioned that. It will be Canada's largest indoor composting facility and one of the top 5 to 10 in North America. Very large. And the reason why it got so big was because we combined the two processes. We combined single-family residential and biosolids into one. And again, this is the first P3 model done in Calgary successfully.